Hi, and welcome to episode 21 of my free Java video course. My name is Markus Biel. In this episode, I'm actually going to talk a bit about various smaller topics. We are still on track, talking about the class object and all its methods. The last two methods I need to tell you about are hashcode and equals. Actually, they are one of the most important methods in Java, I think. However, hashcode and equals are a bit more complicated to explain. So before I can tackle them, I decided to push an episode in between to straighten things up and to talk a bit about the missing pieces in this episode. Okay, so let's start. As you see, I have prepared this demo test class for you. Actually, we're not really testing something today. This is really only to use to demonstrate those few small missing things. So let's do one by one. And the first thing is I want to talk about static imports. You might remember, I think I talked about static imports in the first 3 episodes, and I kind of promised you to later on give you more details about it. The problem at this time was we hadn't talked about static. Well, in the meantime we have. I just didn't have any better opportunity to talk about it, and I felt a bit guilty, so I think now I should really finally tell you what exactly is a static import, how you can use it, and what it helps you. So actually we used it all the time, and you might have seen it. Here on top I have this import static org.junit assert .star. It's just grayed out because at the moment I'm not using it. This is also set here, unused import statement. Now you can see it. And you can also see here the regular import org.junit test. So the question is, what's the difference between the two of them? So this one imports the code of the whole test class. While this one here, a static import, just focuses on all the static methods. Because in JUnit, when we want to test, we always used these assert methods. Assert equals, assert true. Let's do that now, like assert true. You see, my IDE already helps me. True. I mean, true is always true, this is stupid, but I just want you to see the method. And the thing is, this is only now working because I have this here assert, and see, now it's not gray anymore. It turned white because now it's in use. So let's actually have a look at this class. I can jump there. You see, even it says it extends object. Well, no wonder, all the classes extend object anyway. So here you see, I see the decompiled code. This is what my IDE can also do to show me the code. This is very helpful so you understand better what happens behind the cover. So here you see a lot of static methods. So this class actually groups them and makes them usable to me. And as you might know from static, when I talked about static, the way you would use a static method would be normally you say class name dot assert true. Now you can either use the full-fledged class name, which is org.junit.assert and then assert true. Or if you don't want to use the package, you would import the class and then you can just say assert.assert true. Of course, there are also other methods. You can have a look on those by yourself. Actually quite complicated ones, like you can even compare arrays and so on and so forth. Not equals, equals, with message, without, is equals, and so on. Well, we have used some of them. So this means I can also say assert.assert true. But now you see this is not working because I have not normally imported the assert class. So if I would want to do this, I would have to say org.junit.assert and then import it like this. Now you see it's not used anymore because now I'm not statically importing it but regularly, and I'm using the class name to use the method. But I mean, when they introduced it, I think this was with Java 5, the reason to introduce it was to just make these statements shorter, because you don't always want to write assert dot all the time. Okay, and you could also do it as said before without any import. This would even be more longer. Then you could go without the import. No, they're not, see, but there it is working. That's the difference, because now I don't do any import. Let's put it back, and then we can go with or without. And if you want it like this in the shortest form, you need the static import and not the regular import. So that is a static import. And the dot star means just import all the static members. Well, static is not members. All the static functions and also the static variables of the class. So if you have variables you want to import that are static, this also works with the star operator here. But you can also say you import only specific functions or attributes. So this is up to you. Okay, so that's all I can tell you about static imports. I think sometimes they're helpful. More often it actually happens than you would think that you would import several methods or attributes that are the same in different classes. If you have that, it's exactly the same like I told you about the imports. You can only import one method name once by using a static import. If you now have a second class that has the same method, you will then have to use the full-fledged or at least the class name so that the JVM, the compiler, knows in this case I want the assert true method from this class, and in the other case I want the assert true from another class. Okay, so you can't, I mean, there must be a way that the compiler understands what you're trying to do. If I only import this statically once, I mean, then it's just obvious the assert true is part of the assert class here. Okay, so that much about static imports. The next small thing I want to talk about, let's open this up, is default values for different data types. I think this is quite important and also interesting, because I see many people that would have here member variables defined, and then they would say something like here, well, for cards different, wait, like for the boolean they would say false, or for the object they would say null. And you don't have to do that, because null for object as well as false for boolean is the default. So this is, in my eyes, this is just clutter. You write code that you don't have to. I mean, for every rule there's always an exception. For example, if this is very important that this is set to false, and this is really a specific case and you want to give a message with it, it might make sense to sometimes write here explicitly false. But then also maybe you should name your variable a bit different so that it says why this is important. And because my boolean now, I mean, this might be the problem, it doesn't say why this is always false. Okay, so, and now let's have a look at all the different defaults. But when I say default, this really only applies for these member variables up here. If you, for example, have a local variable like boolean b, you can't do that. If I'm now trying to use it, this is not going to work. If b, this will give me a problem. Variable b might not have been initialized. But it does work with the boolean up here. This is going to work. See? And now it will count as false. So the if would not be executed, the branch. Okay, but now enough of talking, blah, 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 blah. You might already be asleep, so wake up. Okay, so let's make this a bit bigger so we can see it properly. Okay. Now, so you see, byte default value, short default value, those are all 0. Actually, there are many number types that we haven't talked about, and this is also what I'm just going to introduce right now, because we totally focused on int, because this is actually the one that is most times used. But as you see here, there are also others. I think I once showed you byte, and I also showed you once car. But there are also others. In my opinion, this is just these smaller data types. We will see the ranges very soon. Are only here because I think like this or similar, they existed in other programming languages before Java, like maybe C, C++. In my opinion, this is the reason is probably because like something like 30 years ago, the memory was so expensive and there was really the memory space was so limited. Like you would have a memory of, I don't know, a few kilobytes. Now with gigabytes of RAM, this is totally a different issue. So the space int uses actually a bit more bytes, but the space is really not relevant these days. In 99 and probably 99.9% of the cases, I always use int. So byte, in short, in my personal opinion, something like deprecated. I mean, this is not true actually, because I'm sure someone can tell me there is a specific case where you would need them. It's just that on average, generally speaking, you should be fine with an int. And we'll look at actually the sizes of these types in a second. So yeah, the long is actually bigger, can save longer numbers than int. This sometimes might be needed, but also not so often really, I think. Now float and double, as the name implies, at least for float, they're both floating numbers, and double, I think the name comes because it's like double the space or something than that of a float. Actually, also these I hardly use because, first of all, I personally did not work too much with these kind of floating point calculations. And second, in case I did, for example, calculating on money, there you would need that. But there they are quite problematic actually, because they don't calculate properly on the cent. It can happen that when you have something like €2.20 multiplied by, I don't know, or divided by a number of people, that in the end you lose or you gain a cent. And like in the financial industry, this is just not okay. So therefore, float and double can't be used there. The reason I can't perfectly tell you, but I think it has to do with internally these numbers are of course stored in a binary format. A computer only knows 0 and 1. And then when from this format it's transferred to our decimal format for those floating point numbers, then there are rounding issues. And therefore, when you really need to have a correct floating point result, there are various other solutions. One is to store the number without a floating point, for example as a long or an int, or alternatively even as a string. And then you do your calculation, and when it's finished, you insert the floating point visually at the place in the UI where it's needed, which is also dependent on like local settings, like numbers are formatted differently in different languages. So therefore, this is usually the way you would go, at least definitely in the credit card or in any financial industry. Okay, so anyway, float and double are both floating point numbers. What is interesting, by the way, is like when you have a constant value, like 43.31, this here, I mean, this is a value, a constant value, and if I just write this down like it is at the moment, this is now by the definition automatically a double. if I want to have this as a float, I have to say the capital or lowercase f at the end, which makes it a float. So if I have like float, my float equals to this, I really have to say f at the end, because if I leave it, I would get a problem because it says it found a double, but float is required. And the same applies actually for int short byte. There it's just the other way around, because there int is the default, and when you want to use a short s equals to 43, this just works implicitly because Java sees the space is fitting, and then it will just implicitly convert the int, because this is really an int, to a short. However, let's try the same with the long 43. This also works because now you try to store the smaller thing, the int, into a long, which should always fit. Okay. So what else? So we have object. The default value is null, as I said before. Boolean, the default value is false. Car, now this is interesting. It depends on if you display this as a car as it is. And then this is, I think it's called the null character. And I think this is just nothing, or maybe space here. You see there is something, it just can't be displayed by my UI. I mean here, if I try, there's nothing blue. But here, when I go over it, it's displayed as blue because there is actually something, it's just not visible. And I can convert this character, the default character, to an int, and then it's a 0. Okay. Now, so these were the default values of the different number data types as primitives. Okay, and now, as the next topic, I also want to tell you, never told you so far, all these number types, they in parallel also exist as objects. Let's have a look and then see and discuss why that is. Okay, so you would have byte, this is used already on top, so let's just call it b equals to byte dot value of. Now this is a static method which can and should be used to convert a byte primitive to a byte object. You can also say new byte, but this is just not recommended because this might use more space. So I don't want to go in details because then I could talk forever for performance optimization, but this is just creating always a new object, while the other one might reuse an existing object of the same value. So this usually is good enough. Okay, there's also other methods, static methods like parse. The difference is this works now on a string as far as I know. Let's try. 2, yes. And let's go into the function. See, I can also see it here. And this converts it not to the object, but again to the primitive. This is the value of. It converts it to a byte. Here even you can give the radix, like the radix of 10 or 8 or 16 or whatever. This usually, well, I never really need it. But there are a lot of functions. What is also interesting is that these objects, they all extend the abstract type number, abstract class. We talked about inheritance already. So here you can see all these different functions that each of those number types have to implement. So each of them you can convert to an int, long, float, double as the primitive value. The green stuff is, by the way, the Java API documentation that you can also read online. Short, so all these types automatically will have. Okay, so back. Now, besides offering these cool methods that might be helpful, there is also another reason why these exist as objects. The reason is, I think, mainly because there is something called collections that we will talk about very soon. I think I even mentioned it shortly. It's something similar to an array. It's like an array on steroids. It's just a container that you can throw in objects, and that's already it. You can only throw in objects. And so you could not throw in any primitive, and therefore this is also called a wrapper type, because this object then will wrap around this primitive type and can be wrapped and unwrapped. Which, by the way, in the past, when working with primitives and collections, was needed. So before putting it into the collection, you would have converted your primitive data type, like this here, my byte, into the object, would then have, let's just say collection, let's just say add. I mean, in reality, it looks a bit different, but just so that you get an abstract idea, you would have added this thingy here, and later on, when you wanted to retrieve it again, you could then say byte dot get the byte value. And then again, there were people saying, oh, this is just too much work. And so I think also with Java 5, there was an auto conversion introduced that now Java can work with a primitive and an object and will automatically, behind the covers, convert a primitive to an object and an object to a primitive, whatever is needed by a certain function. Now this is heavily in use by almost every developer. I really don't like it, and I really activate in my IDE that I get displayed these conversions, because for one, this could even be an issue with performance, because I see functions that would like convert from a primitive to an object and to a primitive and so on, back and forth several times, which is just stupid. Second, for a primitive, you have the default value of a 0. That is safe. That will never throw a null pointer exception. However, for an object, when it's not initialized, like here, the value will be null. And then when you, on an object, call b.byteValue, this will actually throw a null pointer exception. The problem is you don't see it, because it'll be automatically be inserted by the compiler for you. You only see it at runtime, then you get a null pointer exception. So really be careful with these automatic conversions. I personally hardly ever use them. Okay, but so that you know, for each of these primitive number types, there is also the same type as an object. The names are pretty much always the same, like there's a short object. For int, it is integer. So there is an integer. For long, it's long. For float is float, and double, it's double. And also Boolean exists as an object, which, by the way, also has static Boolean object values. So you can even say Boolean b. Now I have to remove the byte, because this is also b. Boolean b equals to true or equals to false. But now this is an object. I can also show you now the automatic conversion works. Even though this is an object, the static value here, we can even jump there. You see public static final Boolean false equals to new Boolean false. So the cool thing when you use this is there's only one object that is always reused, and you don't always say new Boolean to save some space. Okay. And now you see I can assign this object to the primitive type, because internally the compiler will do this for you. You just don't see it. Okay, so that's I think all I can tell you about the different number types and their object variants. Now let's have a look at their ranges. I said, for example, byte in short, they have smaller ranges, but enough of talking. I think the best is I just show you. So execute the test and we see. Let me scroll this down. I think this makes it easier because then we can see the test and the code in parallel. Okay, so here I use the system out println. Remember, don't use it, avoid it. Just here in my test, it doesn't really matter. I just shortly wanted to show you the results. Otherwise, in productive code, prefer logging because it's more flexible and would probably lead, generally speaking, to more performance. Okay, but enough. So here you see, so there are signed types and unsigned types. Signed means, you see, there is a minus, so it goes from minus 128 to plus 127. Interesting is, this is not 128, but 127. Well, here's 128. This actually is for all the signed types. The reason is the JVM in your memory of your computer will actually need this one number to store the information if it's a minus or a plus. And this is why they had to take one number away, and they just decided that minus has one more number than plus. I mean, they could have also done it the other way, but this is how it's done in Java. Okay, so you see, this is only for very small numbers, minus 128 to plus 127. Short is already much bigger. It can store 32,000 something, plus and minus, again one less here on the right side. Int again is much bigger, I think this is like 2 billion or so. Long again is much bigger, I don't even know how long this number is. Yeah, usually you should be fine with int, and in some rare cases you need a long. Yeah, actually sometimes I needed a long. Okay, and then there's here the floating point number with the exponent minus and plus, and the double, see here it even is much bigger, 324 to 308 minus plus. And the car, this one is unsigned, so this is why there is no minus, which is also why the size here is 65,000 something, is the double size then to the short, because the short has the same space, but it needs to have it in a signed form with a minus and a plus. So this is why here we can store 0 to 65,000. Okay, and car, as you have seen before, usually is used not to store numbers, but characters. But if you convert it to an int, you can also use it to store numbers unsigned from 0 to 65,000 something. Okay, I think this is actually interesting to see all these ranges. Okay, so these were the ranges. Let's go to the next. And so in order to be able, by the way, to show you, see here I converted this to ints. And also, this is also interesting. You see, here I used actually the objects, and these are static values which give me the min and max value. This is really handy. When you need those ranges, you can just use them out of the box and say min value or max value, because I wouldn't know them directly. I can just look them up and Java will tell me then. Okay, let's close this now and go to our next test, because now what I want to show you is actually you can also save your numbers not only on the base 10 but also on the base 2, base 8 and base 16. So now it depends. I don't know if you had this already in school or university. Assuming you had, this should be really easy for you to understand that, for example, with the base 2, you would display, a number would be displayed differently than with the base 10. If you never heard of this, then don't mind. This really is not so important. I think I never needed to display the number in one of these formats. Decimal was always fine to me. I mean, this is also the way the value will be stored here on the left side is always the same, no matter which base you use. So this might just be used because you are in a certain domain, in a certain business area where you need, for example, the hex. And so you would, for example, have a documentation that speaks of a hex value. And so you could have the same value as you have them in the documentation here in your code, which would make it easier possibly to look at the code. However, this has nothing to do with how they're stored. I mean, they're still stored on your computer, in your memory, and your computer can always only store them as zeros and ones. So internally, no matter what format you use, internally they're saved always in the same format. And by default, they're also, when I print them out, which I'll show you in a sec, they will also always be printed out on the base of 10, just like a regular number like you know them. So this is only a displaying issue in the code. If you want to display them in the binary format, you need specific formatting options. This will be an episode on its own, so I will not go in detail on this now. Also, I think this is not needed in many cases. What is also interesting, by the way, I mean this base 2 was introduced with Java 7 only, so this only recently got added, speaking as of 2015. Before, you had only the option to store base 10, base 8 and base 16. Now they added base 2. Besides, to make this stuff more readable, I mean especially with base 2, you will get these long strings here of zeros and ones so that you could easily read this. And also for something like credit card numbers, you can add these underscores, actually as many as ever you want. You're just not allowed to do it at the beginning of the string and at the end of the string. But I mean, I don't see how this would make any sense, because this wouldn't help to read it. So this is why you put them here in between. You can also add more, like here. Now the question is that more readable? In this case, of course not. But I think it can be quite helpful, especially for something like credit card numbers, for long numbers, that you can read them more easily. Like on the phone talking to a colleague and you want to read out the number, and then you can talk about the blocks, makes it easier. But these underscores, again, this is just a displaying issue in the code. The way they are stored is exactly the same like before. So now let's execute the test. So that this gets printed out and we can have a look at it. Okay, so here you see the first one, OB. This just indicates I'm storing the number in binary. The number is given in a binary format, so this is just a 0. You can use the capital and the lowercase, it's both the same. So this one is a 1, and this long thingy here, so OB is binary format, and then all this, you can use your calculator and calculate it, and in the end you will see this is this number in decimal format. Okay. By the way, of course, just shortly, binary format means you can't, for example, use a 3. This will give you an error, integer number too large, because now we are in binary format, indicated by the B and 0 here. With the base 8, let's scroll down, it is started with a 0 only, so 0 and 7 means this is a 7 now, but 0, 1, 0 is actually the 8 on the base of 8. As I said, if you know it from like school or university, you will understand what I'm talking about. If not, doesn't matter, not important. Yeah, you will hardly ever need it. Let's have a look at it. So, as I said, this is the 7, this is the 8, and this is some large number. So these underscores are not displayed in here. This is just to help so that it's more readable in the code. And the base 16 hex code is started with 0 and X, and then the 0 is a 0, while the F, in Latin, no, I think our numbers are not Latin, they're Arabic numbers, and these Arabic numbers, they are based on the base 10, so 9 is the last number, and when you want to say 10, you need 1, 0, while on the hex, you don't have any more Arabic numbers, so therefore they used A, B, C, D, E, F for 10 to 16. So the F is actually the 16. Let's execute this. Well, I was lying to you. It's the 15 in this case because we start with a 0. No, yeah, it's the 15 because the 16 again would be 1, 0. Okay, yeah, can get really easy confusing. Sorry. So anyway, I think it's not so important. It's just interesting to show off. Like in a job interview, I think you really should know Java inside out. And so I think you should know that this is possible. The question if you personally will use it, because you personally in your project will need it, I don't know, depends, maybe you need it. But if you need it, it's here to be used. Okay, so now I think really did an in-depth view on all these small topics, and I think this is really now a good base to talk about hashcode and equals in the next episode. This will really be a great episode. I'm really looking forward for this one. Hashcode and equals are very important, so make sure you come back and have a look at the next episode. For this, of course, you can just subscribe to my YouTube channel and you will automatically be informed as soon as I release the next episode. Also, I would be very happy if you give me your thumbs up, a like on this YouTube video in the bottom right corner. Yeah, last but not least, you can leave me a comment below the video. For example, if you say, oh, this guy's just talking too much, tell me in a comment and I might stop it. Yeah, so thanks for watching and see you next time.